I'm Matt Fox from the Mining Remediation Authority, Principal Manager in the Mine Energy Advisory Services team. If there's anything in this chat that you want to know more about, just please feel free to drop me an email. My email address will be right on the back slide, so we can discuss anything in more detail if anything jumps out at you. Skip through my slides. I've been told there's a bit of a lag on the slides, so apologies if it's not quite caught up yet. But the first slide is just a little bit of information about the Mining Remediation Authority itself. We were originally formed as the Coal Authority in 1994 after the privatisation of the coal industry. And this was to look after the liabilities that remained, and it wasn't anticipated to be a long-term thing. It was only supposed to last 18 months to 2 years, but we're still here. We're based at Nottinghamshire in Mansfield, at Berry Hill, and the functions of the Mining Remediation Authority are ownership of the mines of coal and unworked coal in Great Britain, licensing and permitting of any mining or any other mining related activities related to coal. Not that we're anticipating that there will be any future mining that's licensed of coal in the UK. Management of public safety incidents relating to past coal mining. These can include subsidence events and collapse of mine shafts and mine water issues. And then management of mine water related to coal mining, treatment of existing pollution, pumping to prevent future pollution, such things like prevention of aquifers, and mining information. We hold quite a lot of data, both digital and physical paper copies. These are used still for property transactions, site investigations, and projects such as mine water energy. We hold over 100,000 abandonment plans in our archive, and something exciting that has just happened. These are all now available to view on our interactive viewer. So I highly recommend you check that out. There's some real interesting plans on there, and you can quite easily lose a few hours looking through old plans, because I know a lot of us find those interesting. I certainly do. And then we're still a statutory consultee on planning consultations. So if there's any developments in coal mining high risk areas, we're a statutory consultee, and we have to make sure that the development over mine workings are done in a safe manner. So just a little bit about coal mining itself in Great Britain. I appreciate this is very heavy on coal mining. There are other sources of mining in the UK. The change of name from Coal Authority to Mining Remediation is I think that's intended to reflect that, and we are seeing ourselves get involved in more metal mine projects, especially in Wales. But coal in the UK has been extracted from approximately 23,000 collieries. They're all closed now. The last deep coal mine to close in the UK was Kellingley Colliery in North Yorkshire. That closed in 2015, and that really brought to an end deep mining in Great Britain. The Mining Remediation owns the below infrastructure, so we own the majority of shafts, but not all the shafts. And again, we own the majority of unworked coal and the workings themselves. So when it comes to things like the ownership of the heat, we don't own the heat, we don't own the water, but we are the property owners. So you would require access to our property for any potential mine water heat scheme. And then some recent mapping we had done by in conjunction with the OS, and the work that we did estimates that approximately 25% of residential properties in Great Britain sit on former coal working. So as you can see there on the map on the right hand side, you've got the population clusters such as Newcastle upon Tyne, Nottinghamshire, Yorkshire, Lancashire, and a lot of South Wales sit on these abandoned coal mines. And the thinking is that these could potentially be integrated into district heat networks. these could be sources of heating, or as we're now experiencing, this could be a source of cooling, and maybe even a source of interseasonal storage of heat. That's something that's being explored now, and I can talk about that a little bit later. So mine water heat itself, when the collieries were working in the UK, a lot of water had to be pumped for safety reasons to keep the mine workings dry. This had the effect of artificially lowering the water table in a lot of areas, so this was drawn down. When the majority of the industry closed in 1994, a lot of the pumping infrastructure was switched off, apart from a small amount in Nottinghamshire and Yorkshire. And this has led to a period of what we call mine water rebound. So these workings are naturally filling with water from the strata. That means that this water is being heated by the geothermal gradient. Temperatures, probably a modest estimate is somewhere in between 12 to 17 degrees, the temperatures we can expect. That's been demonstrated at Gateshead, at places like Maltby in Yorkshire, and maybe Wearmouth in Tyneside. Wearside, not Tyneside. We're probably expecting temperatures a bit higher, a bit closer to 30 degrees, but they're expected to be the outliers. But these temperatures are shown on our interactive viewer as well. So, a lot of work by my boss Gareth Farr, and we've got a lot of estimates for mine water temperatures around the UK. And this just goes to demonstrate that up until about, I don't know, 10, 15 years ago, these workings were classed as a liability and a source of problems that had to be mitigated against. But now we've kind of flipped that, and now these are a potential opportunity for geothermal projects rather than a historic liability. So what are the major benefits of mine water? And especially, this is comparing mainly ground source heat pumps to air source heat pumps. So the effect that the overlying strata has on the mine water is that it is effectively insulated against surface fluctuations in temperature. So we know by looking at the the seasonal variations in air temperature, temperatures go up and down. And we can predict these. We know how it will occur, but due to the way that air source heat pumps work, they are most efficient in summer when you don't really need the heat. You really need cooling. So and converse to that, the air source heat pumps have to work quite hard in winter when temperatures are around zero to get that uplift to domestic levels. So the graph illustrates that. So mine water, say if you are somewhere like Gateshead, for example, where we have temperatures of 13 degrees, they are constant all year round. So in winter, when you really need the heat the most, air temperature is low, but this mine water has an advantage when it's somewhere between 10 to 15 degrees warmer, so that gives you a better starting point for your heat pump. So that is really why we're trying to get to the mine water. Yeah, and just to summarize that, yeah, that's a very brief summary of that. So how can we access the mine water? There are a number of ways we can do it. We can drill boreholes into the mine workings, which can be risky. Some of the mine plans, such as Gateshead, are approaching 200 years old, and it can be problematic to intersect mine workings with boreholes based on the plans we have. Excuse me, anything say post 1947, following the nationalisation of the coal industry, surveying standards improved, mine plans were standardized. So anything from, say, the 1940s onwards tend to be better quality mine plans where we've got a lot more confidence in hitting the targets. We can also access the mine water from mine water treatment schemes. We have a number of these, about 80 around Great Britain. So these are they're in effect sources of industrial waste heat. So they are facilities we've had to build in order to manage the mine water level. So we pump the mine water, but then we also have to treat it to make sure that it can be safely put back into a local water course. And that's done by building the cascades, aerating the water, getting the iron to precipitate out, and then letting the water run through a series of settlement tanks and then reed beds. And then that improves the quality of the water that it's available to it's ready to be put back into a local water course. The advantage of these are it's infrastructure that the MRA has to maintain, and we have to pay to pump the water. There's the electrical pumping costs. So all the risk has been removed from a project. You don't have to drill any boreholes. The infrastructure is already there. We say it's more akin to a plumbing job than an exploration job. And some of these, such as our mine water treatment scheme up in Dordon, that is going to heat a 450 home social housing development, CM Garden Village. So there should be some news going out in the media about that shortly, which is a very exciting project, and it will be very good when it's done. And we can also access mine water from what we call shafts and discharges. There are approximately 174,000 shafts in Great Britain, and then there's a small proportion of these that remain unfilled. So these were never concreted up or had plugs put in to protect the aquifers. And these are sites where we may currently monitor mine water, or we may have one eye on it being a pumping scheme for a mine water treatment facility in future. And there are about we estimate there are about 100 of these open shafts that could potentially be integrated into a mine water heat project. And again, that would remove the risk of drilling boreholes and not hitting things. And then in areas such as South Wales, there are a number of discharges that were sunk into the hillside to allow gravity to drain mine water from the workings naturally without the need to pump. So briefly touched on this in the past side. So these are some considerations when we have to drill boreholes to access mine water. You have to consider the depth of available workings beneath the site. We know that the drilling costs increase proportionally due to with depth. Current costs are anywhere in between 150 to 150,000 pounds per 100 meters. So if you go down to some of the deeper workings in Great Britain, say High Main or Maltby, if you get down to 1,000 meters, you're talking about in excess of £1 million of borehole, and that can really make schemes uneconomic. We have to consider the quality of the drilling targets. And again, I touched on this in the previous slide. So that's the age and type of workings. Are they pillar and stall? Are they long wall? The perceived accuracy of mine plans. Is this a Gateshead style mine plan from 1820, or is it one from Kellingley from 2015, for example? Available records for some of the mine work. For some of the mines, we have surveyors' notebooks and coordinate ledgers that give us coordinates accurate to the nearest millimeter, and again, that really can ease the concerns of some drillers. And that's another point. There are a number of drilling firms in the UK, and it's really, if you are considering a mine water scheme, it's really important that you speak to like the competent and experienced drillers. So this slide just illustrates some of the differences in types of workings that we look to drill into. So these are pillar and stall workings. These are the type that we've recently encountered in Gateshead. These are some of the newer ones. These are long walls, but they're not quite the modern style with the retreat roadways. So they're supported by steel arches. These tend to stand really well and make good drilling targets. Same as these. If you can find a hole in the, sorry, can you see my pointer on screen? I'm pointing to things. Let me just get Let's get the other one on. Let's get the laser pointer on just to, that's better. So yeah, if you were using room and pillar, if you were targeting mine workings, you'd go for a gap like that. And same as long wall roadways with GOF. If you went for the edges, these roadways would be supported by steel arches. So you'd look to put your bore all around there, and then you'd drop down right in the top of these arched roadways. And again, these are some advanced examples of locomotive roadways. You can see some of the junctions. And again, junctions make really attractive drilling targets because if you get a blockage down there, for example, the water can still flow that way. And then just on to some case studies now. So I've just done a whistle-stop tour through MRA, the different types of workings and the different types of schemes. So Gateshead is a borehole-based scheme. At Gateshead itself, there was a gas CHP heat network installed in, I believe it was around 2017-18, a 6 megawatt gas CHP. Linking a number of government buildings. So you've got the Baltic, the Sage, I think there's a college and a number of like other government buildings. You can see this. I've got a better diagram than this, but you've got the solar farm there that contributes to the heat network. I think that's the energy centre there. I think the mine water heat pumps in that building there. So sometime around 2019, Gateshead decided they were going to move away from gas CHP. They initially looked at the River Tyne, and for reasons I'm not 100% sure of, they couldn't make the River Tyne option work. So they knew this was a historic mining area, so they had some conversations with us, and it turned out there was a good number of workings beneath the site that could make really good drilling targets. They had a number of feasibility studies done, all came back positive, and ended up with us drilling some boreholes at Gateshead. So again, that's just a better image of the heat networks here. You've got the District Energy Centre, mine water heat pump. You've got the solar, River Tyne, Baltic, Glasshouse, Gateshead College. And the benefit of this from the consumer is, I think, with the current economics, they pay 5% lower than the price of gas when they're hooked up to this heat network. And I think one of the unexpected benefits is this private firm, GB Lubricants, hooked up to this heat network, and they actually found by being part of this heat network, it actually improved their ISO accreditations, and it actually helped them with exports, which no one foresaw the onset of this project. And then just get back to the geology, the interesting bit. So what we did here at Gateshead was there was two seams. There was the high main, which is about 50 meters below ground level, and then there is the Hutton seam, which is about 150 meters below ground level. So we have a number of boreholes. So we have two abstraction boreholes down to the deeper horizon. We have one reinjection borehole to the shallower horizon, and then the scheme works by abstracting the warmer water from the deeper borehole, running it through your heat exchanger. Your heat exchanger takes 5 degrees from the mine water. It transfers it to the heat pump, which then runs it through the heat network itself. The cooler water, the mine water, which never goes through the heat network itself. The cooler water is then sent back down through the reinjection well and back into the high main seam. But what you can't see on this diagram is when the boreholes were first drilled, the interconnectivity between the two seams wasn't what we thought it would be. So we had to drill a third, well, not a third borehole, but another borehole, which had the purpose of artificially connecting the two seams and creating this circulation pathway. So that we drilled what we call a vent borehole, and that allows the circulation of water and for this to be sustainable. And so the takeaways from the Gateshead heat network is that it was initially a 6 megawatt heat network. The anticipation was that they would replace 50% of the capacity with mine water, so it would be 50% gas CHP, 50% mine water. But the reality of that, again, it has exceeded expectations, and at peak season, the mine water can supply all 6 megawatts to the heat network, which was like a fantastic boost to us. It's just some, you can just see the borehole chamber and then a CCTV survey of the mine workings. You can just see the fractured roof there of the Hutton at 147 meters. These are just some plans. These are some of the workings from the high main seam. As you can see there, the plans from 1786. So we're really lucky to have these plans in our collection. They predate the 1872 Act that required all mines to keep plans and deposit them with the Secretary of State. The boreholes are actually into an area of what we call probable unrecorded workings. So they're workings that are even older than this 1876 and not shown on any plans, but we suspected they were there from historic site investigation boreholes. That's the deeper horizons. That's the Hutton seam at 150 meters. The mine plans are of a better standard. I think, yeah, you can see there, they're 1926, but they still represent some problems with georeferencing these to modern features. We had to use OS County series plans as intermediaries. We had to use things like churches and bridges to try and tie the old maps to the current OS mapping. The margin of error we think was plus or minus 10 meters. So the drilling was quite problematic. We weren't 100% sure that the boreholes were going to intersect the intended targets. So we had to do a bit of an exploration program, drilling on a grid. I think somewhere in the order of 12 boreholes were drilled, and we found mine workings in 3 or 4 of them. So yeah, we had to do a little bit of work to find the workings, but it worked. We found them, and the scheme has been a tremendous success. But just to contrast that to something that was done more recently, this was actually a coal mine methane borehole. So this was a borehole that was drilled in 2009. It was for the purpose of abstracting gas, but when we got down to a level of 840 meters, we found that the workings were actually flooded, so it wasn't suitable for what we needed. But the borehole itself was a technical success. The borehole had to have a surface deviation of 149 meters, so the borehole had to be steered to avoid workings in an upper seam. So the borehole started off vertical to get through the Permian aquifer, and then it veered off to avoid these these top hard workings, not high main. And then it proceeded to a depth of 840 meters below ground level, and that intersected a 3-meter wide roadway. So it just shows what can be done if you've got the appropriately skilled drillers and the budget to be able to do things. You can hit workings at depth and be confident in these plans. Again, these plans are from, I think these are early 90s, so the plans are good. The only thing here that would stop you is the budget. I mean, this was £1 million borehole in 2009. It would cost more than that now. It would probably not be feasible in a district in a heat network. It would just be too expensive, unless the economics change. But yeah, it just shows an example of what can be done when you use the right drillers and use the right targets. That's just an example of some of the additional data we hold. These are the survey ledgers, and it just shows the quality of the plans and the accuracy. And it's down. These things were surveyed to millimeters with laser surveying equipment. And if you show these to drillers, it really does like put the minds at ease. They say if you're aiming for a survey station like that, they would say, oh yeah, we're happy with that. We're not worried about missing a target at 600 meters. That's just a summary of Gateshead. I think I've been through most of that. Probably not mentioned the flow rate of about 140 liters per second, which is good. It can provide the 6 megawatts. There is a scheme adjacent to this at Lanchester Wines, which I will show you next. So Lanchester Wines was the first mine water project in the UK. This was a fully commercial one. I don't think there was any government funding used in this, and this was to there was a wine warehouse with a large space heating problem. So the intention was to use the mine water to keep this wine warehouse at a constant temperature and help with their business model. So they've got two heat pumps, two different sites, Abbotsford Road, 2.4 megawatts, Nest Road, 1.2 megawatts. They've got extraction rates of 30 litres per second and 70 litres per second. It's a large beverage warehouse, privately operated, and this is live. And one of the issues here is you have two schemes that are next to each other, and they're effectively could be competing for the same resource. So we've had to install a series of monitoring boreholes between the two schemes, known as the Living Lab. We've been collecting data on the Living Lab, and that data is open access. So if you wanted to you could request the data, you could model the data, and you could see how these two schemes behave, and you could see how the heat behaves underground, things like that. It's a really interesting data set, and I would highly recommend having a conversation with my colleague Fiona Todd if this is something that you're interested in. This is Seaham Garden Village. This is one that I touched on earlier. So this is a scheme that's going to go live shortly using one of our mine water treatment schemes, Dordon, developed by Durham County Council, Carbon Homes, Esh Group, funded by HNIP. Excuse me. 3 megawatts of heat potentially, but that could be expanded. I think there was a private development, so there's going to be 750 social houses and potentially another 750 private houses. But for political reasons, I think only the social housing could be hooked up to the mine water scheme in the time frame that we had. And that's currently in construction, but hopefully there should be some movement on that one very shortly. And then the last example that I have for you, this is Thermal Earth. So this is a scheme that uses our Lindsay treatment scheme in South Wales. So this is a different way of using a mine water treatment scheme. So instead of using the water that is pumped out of the ground and then treated, we drop a heat exchanger directly into the treatment lagoon. So this is a piece of kit known as an energy blade that's dropped straight into the lagoon, and then the pipe work goes into the neighbouring factory, which you can see the name of the firm there. They also produce heat pumps and design schemes. So this is a really good project, and it's got some really good publicity. Again, this was funded by Innovate UK. And there's about 40 kilowatts of heat there. There's enough for that factory, but should the need arise, they could up the amount of heat that they extract from the energy blade. And if there's some development close by, they could even look at using the water that's pumped from the treatment scheme, similar to Seaham Garden Village. So again, this is one that could be scaled up at pace if required. And yeah, this is live. And so that really is a whistle-stop tour of the story of mine water heat so far in Great Britain. There's a number of schemes that we've worked on. There's some in development that I can't really mention. We've got a large one up in the northeast of England for an NHS site. There are a number of local authorities around the UK that are still pushing this, but they've really struggled with there was a funding stream called the Public Sector Decarbonisation Scheme, and this was a scheme that was really comfortable with funding mine water projects, but the government pulled that. And it's not a direct replacement, but the Green Heat Network Fund that can really struggle with some of the risk around mine water projects. When you're doing your techno-economic feasibility, mine water really struggles with head-to-head comparison, say with air source or industrial waste heat, and it comes down to the drilling element and the risk associated with drilling. So that's something that we're looking to address. And then I should have had a slide on this, but apologies. But my colleague Fiona Todd, who I mentioned, she is trialing some heat storage experiments up at the Geo Observatory in Glasgow, and this will be the first time, I believe, in the world where heat has been pumped underground to see how it behaves and to see if we can get it back. And that's all focusing on the interseasonal storage of heat. Can mine workings be used for interseasonal storage of heat and heat balancing? And that would really add another element to these projects and possibly make them more competitive with the likes of the Green Heat Network Fund. So, yeah, again, there's the email address for our team. Mine is Matthew Fox at miningremediation.gov.uk. If you want to drop me a line or ask any questions, that's no problem. And yeah, thank you for coming along, and thank you for listening to my talk today.